the head of AI practice, Newgen Software. Please welcome Mr. Rajan Nagina. Rajanji, for the keynote address, and this is a very important. Mr. Dugal, can I request you to please take seat for 10, 15 minutes? I know it's very important. May I request all of you to kindly come up in front, if you can? Thank you.
How do I change the slide? Is there a way I can change the slide?
I'll just assist you.
How do I change the slide?
You have time. So I'm the only the MC here. May we have from the Audi anyone for the slider for changes? Thank you. Thank you. They will change it automatically.
Okay. So if I request, please change the slide, you will do it, right?
Yes, sir.
Okay.
Yes,
Yeah.
now
How do I do it? I say please. If I may ask, how many of us here are engineers, developers? Like, how many of us are, like, do we build software? Okay. Okay. Hi, good evening. I'm Rajan. I lead AI business for Newgen Software. The talk for today essentially revolves around how do we build software. First, sort of learn a little bit about the evolution of software, which is certainly very obvious, but we'll talk about it a little bit. And then we see how do we build softwares that is coming up. We heard people talking about the AI, quantum chips, the quantum security. And that means we are looking at building systems which has cognition in it. You build software which can think a little. You build software which can do a little. And progressively, this little become little more and way more. So today we'll talk about how do we go about building them, and is there a virtue of building such softwares? Can you move to the next slide, please? Yeah, so simply saying this is essentially very obvious, right? Cloud gives you computing. There's no big deal in it, right? We want to have machines, we go and sort of spin off on cloud. The underlying stuff is like very powerful. Now, once you get computing, you also build software around those computing. Like whole SaaS business came up because we had cloud. You could do mobile apps because we had cloud. And that means once you have this software as service, once you have mobile apps, you could do things which used to take a lot of time. For example, in early 2000s, even late 2000s, if you have to build a website, you would really think about, okay, how do I build a website? How do I build code? How do I deploy it? How do I manage it? Today, if you have to build a website, you go to Wix.com, sort of use Wix.com to build a website in a matter of minutes. So the idea, can you just, it distracts a lot. So simply saying, cloud is not just computing. It enables consumers to do things that wasn't possible as fast few years ago. Now with Gen AI, we get cognition, right? The element of computing moved to the element of cognition, the element of thinking. And hence, there is a possibility that one can build, and obviously people are building, including us, software that can act like human, software that can behave like human. And that has deep impact on how we, as consumers, how we expect our software world to be. For example, Alexa, everybody uses it, right? Okay, play a song, close curtains for me. The spectrum of this intelligence can be as simple as asking things that sort of sounds very mundane and happens, and can also be as complex as asking ChatGPT to say, plan it for me, how does it happen, what is quantum computing, what is difference between cyber security and quantum security. You can literally go ahead and sort of ask things which are relatively deeper. All of this, like the ability to do things fast coming from cloud and SaaS and apps and mobile, the ability to build software or the foundational systems that has cognition to it, and then putting it all together, the world that we live in, we start like imagining, thinking, and touching and feeling softwares which behave like humans. And I think that's the whole construct. Going forward, we see software as having two things. One, a human-like cognition, and a human-like behavior. Can we move to the next slide? Now, this is sort of stating something like obvious, right? This is something that we have felt, we continue to feel and experience. This is banking, how banking evolved. But if you take a moment, because, and that's why I asked, how many of us are essentially the one who build software, or at least, let's say, be part of the software building ecosystem? If you look at just, like, pause for a moment and think through why it took so much time. Like, why all of this did not happen in early 2000. All of it took so much time. Like, what is obvious today, why it wasn't that obvious 10 years ago? Because anything that happens essentially move forward based on the technology evolution that happened. Like, initially, the whole graphical user interface that came in personal computer essentially made us use computer more. Like, you could do spreadsheets, you can have like whole Windows stuff. Then the evolution happened to network computers, or databases, things wherein one centralized system can act on as like a brain to a peripheral system, right? I can do railway ticket booking on one terminal, and all of this ticket booking happens on a centralized system because of network and databases. And then came in whole cloud computing, mobile apps and whatnot, right? So the evolution that takes place as it moves forward start looking obvious today, but there is so much work has gone behind it to make it obvious what it looks obvious today. And hence, if you look at in the current paradigm where we are, can we move to the next slide? We hear a lot about AI agents, and we hear a lot about agentics. And all of it, if you look at last 1 year, the way it has panned out, like if you think of it, right, simply saying analytics, machine learning, deep learning, large language models, there is so much to even wrap your head around. And then you start thinking about AI agents, agentics, and like it's packed with so much vocab, so much nomenclature. But as we said, right, technology evolution take place, and based on those places, we start building things which are non-obvious, and then they become mainstream, and then they become obvious, and then next technology shift happens. What is agentic? Or if you simply say, how do we demystify agentic, and everybody can have their own definition to simplify, because mathematically is there only one definition, but to simplify. But if you have to imagine a software that acts human-like, there are only two things. It thinks human-like, or at least it has ability to think, and second, it has ability to do. That's what agentic means. AI that can make decisions, and also AI that can execute those decisions. It could be as simple as playing a song for you, and it could be as complex as figuring out what is happening in an audio call, or figuring out what is happening in 1,000 audio calls. The anatomy of this whole agentic thing, it's relatively complex, but if you think through it, like from a framework standpoint, it's much simpler. There's general level of intelligence available in large language models. You can ask, write me a poem, it really writes a poem beautifully. So there is a lot of general level intelligence available. You want to take this general level intelligence, contextualize it for yourself. If you're an organization, you are a bank, you are a fintech, you are taking this general level intelligence and passing it through 3 layers. As simple, 3 layers. The data you have, it's just that to take this general level intelligence and to bring it to your world, the data requires to be present in a different way. The data infrastructure requires to be a little different. And hence what you build as a data layer, the power of the system is what was available a few years ago was looking at the structured data that is in a more like a CSV form and you can look at it. Now you can look at data that is a little non-obvious to understand. A customer service chat. It is such a wonderful thing to have. If you go to Policy Bazaar and you want to do customer service, most of it happening through chat. It's so asynchronous for the consumer. It's so lovely, right? I'm working, but I'm still chatting. I'm getting my stuff sorted. And if one has to understand this chat, what is happening inside it, not for one customer, but rather, let's say, 1,000 customers, that ability has to be organized in some way. So one is structured data, and then all other kinds of data present in documents, chats, audio calls, whatnot, all of it, put at a data layer. Then, sorry, it has to come back. I mean, I'm hoping it is making sense. If it is not, then we can really run fast. Making sense? A little? Yeah, okay. So, and second is, okay, the problem is I have general level intelligence. I want to bring it back to like my own org. I'm going to use this general level intelligence for myself to make better decisions and whatnot. So one, sort this data thing. Second, build a brain. Now, building a brain seems like a very super complex, hard thing. It's not really. Like you can decide how difficult or how competent brain you want to build for the purpose you want to solve. You can simply build a brain by providing prompts to your language models. It's a very simple brain. It works. You can build the brain by not just prompts, but rather more complex, something called agent orchestration layers and whatnot. But essentially write stuff that interprets this data, figure out this context of data, pass it on to a general level intelligence system, blend with, let's say, more advanced systems if you have, let's say, figured out more custom models that you have built in, put all of it together to solve the problem that you're likely to solve. And finally, then give it a personality. Like the application layer of this data and brain put together can be an app, can be an API that integrates within some other workflow, could itself be a system that is smart enough. That is where the application becomes a tangible manifestation of the agents. Put all this together, you get an agentic system. Agentic systems are nothing but the system who think and can do. While once you have sort of figured out, built all that, there are other constructs that such software need. Constructs like, I think Sir spoke about the legality aspects of things. If AI makes a decision, who would you hold responsible for? But before legality comes ownership. Before ownership comes transparency. I made a decision, a system makes a decision. Do we know what went behind making that decision? Do we know, can I go back and ask to replicate the decision? Can I look at on what data the decision was made? For example, let's say I applied for a loan, AI system looked at my thing and say, yeah, not so rich. Maybe not 2 lakh rupees personal loan, but 1 lakh rupees personal loan. I got this loan. After 2 years, I defaulted on the loan. Like, okay, personal loan. Maybe after 7 months, I defaulted. May not be, 10 years is not that long. So let's say I defaulted in 7 months. Like somebody want to say, what was, now 7 months, Rajan, like the day that I got the loan versus 7 months in time, I may be a different person. I may have suddenly gotten a little lucky and a more, let's say, wealthy person. One has to go back and figure out what data was there for me, what data the model was trained on. So you basically should be able to go back and figure out what happened, how the decision was made. That's transparency. So when you build systems like that, sorry, you have to still go back to the slide. Yeah, that's it. So yeah, so basically, making a software that can think is a necessary, but not a sufficient way of doing things. You're going to have contour systems, for example, that talks about how does it answer questions, how does it look at the responsibility aspect of all of it, like basically putting together all of it. Now go to the next slide. Yep. Now this is, Sir spoke about capability building in quantum computing. Essentially, it's capability building in almost everything. It's such obvious that there's no reason for not to use it. I mean, certainly there are reasons to say, how do I use it? How well I use it? If I use it, do I have guardrail systems to protect for it and whatnot? But there's absolutely no reason to not use it. You have got cognition, you have got execution put together, and the impact is across the board. Obviously, if somebody else does things for you so fast, you reduce the cost. Customer experiences, because it can really understand who Rajan is. And if you can really understand who Rajan is, you can engage Rajan in the way Rajan wants to. Revenue, of course, right? Engagement leads to monetization anyway. There is a little bit of competitive advantage in starting this out fast, because I come from technology and AI background both, and you generally take time to build systems like this. You take time to adopt to systems like this, and hence it's sort of important that you get going faster, and hence sort of build. And since it is, you're leveraging general intelligence on your data, you're leveraging general intelligence to contextualize on your data, make your workflows better, make better decisions and whatnot, and that means certainly you're building advantage for yourself. Can you go to the next slide, please? Yeah, there is so much magical aspects. What is real, what is not real. Read the word not real yet. It's not that it's not real, it's not going to be real, it's not real yet. But some of the aspects, right? It really does stuff, and that means you can look at it and ask it to do things for you. Co-pilots, all of us know, and co-pilots are sometimes very, very helpful. The way you change your workflows, for example, and some of the workflow could be very, very complex, and still you can have systems that can help you out. For example, underwriting workflows. Underwriting workflows are generally very complex, like a lending journey workflow, early warning system workflow. So some of the workflows generally tend to be, there could be workflows. Can we please shut the door down? Yeah. I have a request to close it fast, so we can do that. Okay, so we just move forward. Like I'm stating the obvious. Okay, why this slide? A case in point. Can you just close this door? Like it's really very distracting. It's a lot of noise around. Actually, the case in point is very, very tightly linked to closing the door, and I can tell you why. Like you are, so when you make a commitment towards anything, you make a commitment towards investing yourself in technology, you make a choice of doing something. At that time, it also means making a choice of not doing something. You can be either in the room or you can be outside the room. This is case in point is exactly that. Whatever I spoke about, the conviction of leveraging general intelligence, building software of tomorrow, softwares that can think, software that can act like human, think like human, behave like human, is a conviction that we have at Newgen Software, and that's what I wanted to mention. Can we just, yeah, you can either be in the door or outside the door. Can we just move to the next slide? This is it. I was wanting to say how does our agentic platform look like? You can simply break this down into two. The left three thing actually does things, either a workflow or a content system or a customer experience system. And the right two things actually make decisions. Putting together, you think, you have cognitions, and then you can execute them. So that is our platform. RBI use this, so not just agentic is sort of a thing that is getting built, it also being used, and as I said, RBI using it, so there is virtue in this. We can go to the next slide. Some of the deep, as I said, agents have personalities. The beauty of agents is they also have purpose. Like you can't build agent without have a purpose. All of these are deep vertical agents, they have a purpose. They are again built on the same platform, but they do play, like they do solve some very purpose, goal-oriented problems. You can visit our booth and see some of this in working. And the last slide, if we can. And this is it. Like when I said, you got to build a system that acts like human, you're also going to build a system that has trust layers in it. Decisions must be sort of trusted and whatnot. So you can, these are again the layers that make the trust possible in the software stack. Thank you, that was the last slide.